Hey guys, welcome back to the channel. Did you know that a DC current is used to charge your phones? But wait, don't you plug in your charger into the sockets which receive an AC supply from the mains? Well, you're absolutely right. But it's also important for you to know that if we use an AC supply to charge your phone, then you would have to keep it continuously plugged to the mains. This is because we have no means of storing AC charge. This makes us resort to DC, which can be stored, and hence we do not have to move around all the time with our phones connected to the supply. Hence, we need to convert this AC into DC, which is done with the help of a PN Junction Diode, which allows current to flow in only one direction. What is a PN Junction Diode and what are its characteristics? These are the questions that we'll be covering in our video today. A PN diode is made of a P-type semiconductor and an N-type semiconductor. The P-type semiconductor has holes as its majority charge carriers, and in N-type, the electrons are present as its majority charge carriers. When we bring the P-type and N-type semiconductors in one crystal, then a junction is formed. What happens is that the P-type having excess of holes and N-type having excess of electrons are attracted to each other. The place where these two semiconductors join attract the electrons and holes towards each other and diffuse. This process is known as diffusion. A layer is formed between the two junctions and is termed as the depletion region. The electrons will be repelled by the negative ions on the P side. Thus, a potential difference is developed across the junction and is known as junction potential difference. The junction potential difference is 0.7 volt for silicon and 0.3 volt for germanium. This junction behaves differently under different biasing modes. Biasing refers to applying an external voltage in the PN diode to help the flow of current. The output of the diode is dependent on how it is biased. Junction diode biasing can be divided into three parts: zero bias mode, forward bias mode, and reverse bias mode. Let's first learn about zero bias mode. In a zero bias condition, no external voltage is applied to the PN diode. Thermal excitation or optical excitation basically gives energy to the electrons to conduct in the form of heat or light. Minority carriers are the charge carriers that are present in less quantity. In the P side, the minority carriers are electrons, and in the N side, the minority carriers are holes. When the junction potential is formed, these minority carriers, which are electrons in the N side, flow towards the P side. This leads to the formation of an equilibrium between the two sides. Under this equilibrium, no current flows through the PN diode. In forward bias mode, an external voltage is applied to the diode. Here, the P region is connected to the positive terminal of the battery and N region is connected to the negative terminal. The negative terminal of the battery gives the electrons enough energy to overcome the junction barrier potential, and as a result, charges flow from the N side towards the P side, that is, from the negative terminal towards the positive terminal. Hence, a current flows from positive terminal to the negative terminal. The increasing negative voltage leads to decreasing potential barrier. The region where the sudden spike of current happens is called knee voltage, as depicted in the graph. Next, let's discuss the reverse bias voltage. In reverse bias voltage, the situation is reversed. Here, the battery's positive terminal is connected to the N side and the negative terminal is connected to the P side. This leads to the electrons being attracted to the positive terminal of the battery and holes being attracted to the negative terminal of the battery. This widens the potential barrier between the two sides, but there are a few minority carriers present on either side. These minority carriers flow from P side to N side, constituting the current. However, the magnitude of the current is in the order of microamperes. If we continue to increase the reverse bias voltage, it will lead the diode to overheat and break. In order to prevent that, we use the ZENER diode. We'll learn more about the ZENER diode in our next video. In this video, we learned about the different biasing modes of a PN junction diode. We'll see you in the next one. Until then, bye.